we are going to prove that the commutator between the position operator and the momentum operator are along the same axis, so x and p is equal to I h bar. And reminder that the commutator is defined as of any two operators a and b as a times b minus b times a. And what it actually means is that we would like to see if the action of b on some given eigenstate psi would affect the action of a. So is the order of applying the operators, does the order of applying the operators matter or not? And if it does matter, then these two operators cannot share a set of eigenstates in quantum mechanics. So we're going to start off by applying the commutator itself. And I would like to note also that the commutator itself is also some sort of an operator in a general sense. So we're going to apply this operator on a generic state psi. We don't care what psi is at this point. And so we'll expand it as written above. So it's going to be x times p minus p times x applied on the state psi. And we're going to distribute psi, bring it inside of the brackets accordingly. So it'll be the x operator followed by the position, followed by the momentum operator applied on psi minus the momentum operator applied on the x operator applied on psi. I'd like to note on the side that these operators act in the following way. So x operated on any state psi will just give you the exact same state psi multiplied by x, while in this picture the momentum operator applied on psi is equivalent to taking the derivative of psi with respect to x. Obviously we're assuming a one-dimensional system, so we can take the exact derivative, not a partial derivative. And so we get to the point where we have, substituting that in, we get x minus I h bar, the derivative of psi with respect to x, minus I h bar d by dx of the entire state x psi. So it's different. So the derivative is applied on the multiplication x psi together in this case, which is different from the one on the left because the derivative only applies here to psi. So what we get is minus I h bar x d psi by dx. And we'll just use the chain rule to get the following solution. So we'll get plus I h bar. So you get the derivative of x with respect to x multiplied by psi, plus the derivative plus x multiplied by the derivative of psi with respect to x. And we just distribute the I h bar on both. Now, obviously also note that this will equal 1, so get minus I h bar x d psi by dx plus I h bar psi plus I h bar x d psi by dx. And we notice that these two terms cancel, and we're just left with I h bar psi. And so the commutator of x and p applied on psi must equal I h bar psi. So we can conclude that the position and momentum operators do not have a zero commutator, and they are equal to I h bar. Hence, they cannot share a set of eigenstates